Welcome to my presentation. In this presentation, let us show that I dot I is equal to 1. Let me write that. I dot I is equal to 1. J dot J is equal to 1. K dot K is equal to 1. And also, we want to show that I dot J is equal to 0. J dot K is equal to 0 and K dot I is equal to 0. We want to show that we've been talking about these properties, but I want to show you that there is a way to arrive at these solutions. So if I were to draw a graph which is represented in this manner, if I were to take, if I call this as my x-axis, if this is the x-axis, and if this is the y-axis, and if this is the z-axis, and if I were to take a unit vector here from the origin, if I go 1 unit, if this is I, and if I travel 1 unit on the positive y-axis, if I call this as j, and if I travel 1 unit on the positive z-axis, and if I call this one as k, and if I were to represent this as a cube, I can represent that. So in here I'm going to draw a block here, and I'm going to draw a block here. I'm going to complete this block here, and this is going to be 1 unit. If I were to consider it as a cube, every side will be 1 unit. Okay, so that is how this is going to look like. And therefore now if I have to represent, if I want to find the angle between I dot I, we're going to resort to the information what we know. I'm going to write that as step number 1. We know the angle between two vectors. If this is a vector and if this is another vector, if I call this as vector A and if I call this as vector B, and if we want to find the angle between these two vectors, we know that it is given to us as cosine theta is equal to vector A dot vector B divided by the magnitude of vector A times the magnitude of vector B. That is the way it is given to us. Now, instead of vector A and vector B, the vector A is vector I for us, and vector B is also vector I for us. And therefore, if we want to find the angle between these two, the way to do that is as follows. Cosine theta. Now, one other observation I want to make here is that if I have I as a vector, and if there is another vector which is right on top of overlying on the existing I vector, that means the angle between those two vectors is going to be 0, isn't it? Therefore, theta is going to be equal to 0. So therefore, cosine 0 is equal to vector A is I, vector B is I, divided by the magnitude of vector A times the magnitude of vector B, isn't it? That is how we want to think about it. Now, we want to find I dot I. We want to find vector I dot vector I. So we want the dot product of that vector I dot vector I, and that we can write as the magnitude of I times the magnitude of I cosine theta. I just rewrote this in this form. I want to write these vectors in here, and therefore when we look at this one, when we look at this, the length of the magnitude of vector I is 1 unit. the magnitude of vector I is 1 unit. The value of cosine 0, this is 0, the value of cosine 0 using our calculators, using our scientific calculators, if you enter cosine 0, the value is going to be equal to 1. So 1 times 1 times 1 is equal to 1. So therefore I dot I is equal to 1. Therefore I dot I is equal to 1. Similarly, we can show that J dot J is equal to 1. Similarly, we can show that K dot K is equal to 1, right? Because if we take the unit vector in the J direction, the length of J vector is going to be 1 unit, and if we were to dot product with another J vector, the value is going to be equal to 1, very similar to what we have seen in here. I dot I is going to be equal to 1, therefore similarly J dot J will be equal to 1, and K dot K will also be equal to 1. Now, on the other hand, we want to see what happens to the other other type. The other type is what happens to I dot J. What happens to I dot J? We said the value is going to be equal to 0. According to what we know is the cosine of an angle between two vectors is given to us as vector A dot vector B divided by the magnitude of vector A times the magnitude of vector B. That is the formula which we have talked about, or that is one of the properties which we talked about. In here, vector A is I for us, and vector B is J vector for us, because we are looking at vector A as a unit vector and vector J as a unit vector. Therefore, we want to find the angle between these two. And if you look at the if we look at the diagram which we just drew here, the angle between I and J is 90 degrees. The angle between I and K is 90 degrees. The angle between K and J is 90 degrees. So keeping that in mind, the angle here is theta is equal to 90 degrees. Theta is equal to 90 degrees, and therefore coming back in here, cosine 90 degrees is equal to I dot J vector I dot vector J divided by vector I, the modulus, the magnitude of vector I, times the magnitude of vector J, right, like that. And therefore we can now come back and then say vector I dot vector J is going to be equal to the magnitude of vector I times the magnitude of vector J times cosine 90 degrees. And as we know, the magnitude of vector I is 1 unit, the magnitude of vector J is 1 unit from the figure which we have just seen, and then the value of cosine 90 degrees using our scientific calculators, that value is going to go to 0. That value is equal to 0. So therefore, the value this 1 times 1 is 1, 1 times 0 is equal to 0. So therefore I dot J, vector I dot vector J is equal to 0. And this is what we have proved, and this is what we have been using in our example problems in my previous presentation, and then we will use this moving forward as well. Now, having said this, we can also therefore say similarly vector J dot vector K is going to be equal to 0. Vector k dot vector I is going to be equal to 0. So these are the properties of vector operations in 3 dimensions, and these are some important properties which if we keep in mind, or if we utilize them, we should be able to solve these example problems in a much more easy manner. In my next presentation, we shall look at some more examples using vector operations in 3 dimensions, and we will use the properties associated with them to solve some problems.